Hello students, welcome back to yet another video on statistics. In our today's video guys, we are going to learn one of the fresh topic measure of a dispersion, which is from the statistic chapter. For similar videos guys, you can check in my I button, or as well you will get these videos in my description box also. I already uploaded plenty of the videos in my channel, so if you're interested to see this video, do check in my playlist. So in my today's video, I'm gonna explain to you all measure of dispersion. Okay, yes. So what is actually the meaning of dispersion? If we take word-wise meaning, okay, so measure means we are measuring. What we are measuring? Dispersion. We are measuring dispersion, but from where we are measuring? We are measuring the scatteredness of a data or like a numerical calculations. Okay, that dispersion we are learning here, and we are trying to find its the measure. Okay, so that's we consider measure of a dispersion. In simple language, meaning of a dispersion is the scatteredness. Okay, you already familiar with the scatteredness. What actually the scattered means sunlights are scattered. You already learned that word. Scattered means it's like getting to the every direction. Okay, so it's falling to the every direction. We consider it is scattered. Okay, so similar concept applied here to the data. Okay, numerical data. Whenever we have scattered data, okay, that means it is not organized properly, or it is like a scattered data. Okay, yes. So for that scatteredness, we use a dispersion. Okay, so we use some measure for that dispersion. Okay, yes. So to find whether measure of that central tendencies are true, okay, to find the measure of that central tendencies are true. So what are the central tendency? We learn measure for central tendency. In my previous lecture, I explained to you our measure of a central tendency: mean, median, mode, harmonic mean, and geometric mean. Okay, these are the central tendencies that we learn. Okay, so what is the connection between dispersion and this central tendency? Whether these central tendencies, the data from that central tendencies are true or not. Okay, whether the representative data can be calculated using the dispersion. Okay, yes. So we use the dispersion to calculate data from the central tendency. Okay, yes. Now see that for finding the dispersion, we use the two method. Okay, we use the two method. Let me write the meaning for dispersion here. Okay, so dispersion means a scatteredness. Okay, scatteredness means dispersion. Okay, this is the actually meaning for scatteredness, and already you all have learned some method for that scatteredness in your 12th standard. Okay, so one of you are the familiar mean deviation, then another one is the standard deviation. Okay, there are the two method. First method, and we have another second method. Okay, first method we know that it is a mean deviation. Okay, mean deviation. Mean deviation. And next, standard. Okay, these two types of the method we use for finding the measure of a dispersion or measure of a scatteredness. Okay, mean deviation and standard deviation. You all already learned the standard deviation can be denoted by sigma. Okay, and that sigma, which can be written as square root of ENPQ. Okay, that one is the part for your 11th 12th standard. I'm gonna go for taking some reference from this basic concept. Okay, and that I'm going to apply over here. So let's go for the first method, mean deviation, just for measure of a dispersion. Okay, so to find out measure of a dispersion, we use first method, mean deviation. Okay, so we have some formulas. There are one or two formulas for finding the mean deviation. We are going to write this one only. So mean deviation it applicable for the grouped data and ungrouped data. Okay, it is common everywhere because see that in statistic we have two types of the data set. One is the grouped data and another one is the ungrouped data. Okay, so as we have learned this concept in mean, mode, median, this type of the central tendencies. Okay, similarly concept it is here for group data and ungrouped data, but just result are going to change as we have mean deviation. Okay, yes, so mean deviation can be found. Now see that first of all I'm going to explain it for the ungrouped data. Okay, there is we have two forms, which is the ungrouped data, okay, ungrouped data. Yes, for ungrouped data, that means we have raw number of variables or some observations are given. Okay, like x1, x2 up to xn. These types of the raw numbers of variables are given. Okay, that means we consider all this variable as xi. We consider this all variable as a xi. Okay, yes, and total number of variable, these are the total number of variable. We have n number of variable. Okay, so we are using this xi and n for finding, we use that xi and n for finding the mean deviation of ungrouped data. Okay, yes, for ungrouped data. So let me write the formula. It is way easier guys, not that difficult. Okay, mean deviation can be found, summation I which is equal to 1 to n. Just write down the formula, because see that some formulas we just have to write, okay, at the beginning. For understanding that formula we go for some of the example. Okay, so mean deviation can be written as I which is equal to 1 to n modulus of xi minus x bar. Okay, total divided by completely divided by n. Okay, yes, so this is the formula we use for finding the mean deviation for ungrouped data. Okay, ungrouped data means x1, x2, xn, these are all xi. Okay, so now see that we are going to just understand the variable xi, x bar and n. Okay, xi means x1, x2, xn, all these are the xi. Okay, that is easier to understand. n means how many times these numbers occur. Okay, like x1, x2, xn, these are the n numbers here, so that's why this n is here. Okay, yes, and what about for that x bar? It looks something new here. Okay, so let me explain what is the x bar. X bar means actually the arithmetic mean. X bar means arithmetic mean for this data. Okay, x bar means arithmetic mean. What is this x bar? X bar means arithmetic mean for this entire data. Okay, yes, now see that n, it is, we are knowing here that n, what is n, x bar and xi. Okay, so it is way easier for finding the mean deviation of ungrouped data. Okay, now let's move for the data which is in the form of grouped. Okay, yes, so for finding the group data, for every data x1, x2, x3 up to xn. Okay, from x1, x2, x3 up to xn, we have corresponding frequencies f1, f2, f3 up to fn. Okay, we have corresponding frequency f1 to fn we have here. Okay, yes, now see that in ungrouped data we have only the raw type of data present, like x1 to xn, some sort of the data sets given. Okay, but in a grouped data we know that along with these class marks, okay, or class values, or like a random x1 to xn, we have given their frequencies also, f1, f2, fn. Okay, yes, and we have to advance this formula for grouped data. Okay, yes, let's find out for the group data then. Okay, so we write mean deviation. Okay, mean we write mean deviation for the group data is a summation of fi. Okay, summation of fi under modulus xi minus x bar. Okay, and total divided by summation of fi. Okay, and which we write summation of fi, we know that summation of fi can be written as capital En also. Okay, so don't get confused about these two notation, both are having similar meaning. Okay, so now see that the grouped data, whenever you have x1 to xn data sets along with the f1 to fnr frequencies. Okay, so mean deviation, how can we write the mean deviation for these data sets? See that these are the f1 to fnr frequency. Okay, that means these fi are coming here. Okay, under modulus xi means x1, x2, x3, xn. X bar means arithmetic mean for given data set. Okay, so arithmetic means x1 plus x2 plus x3 plus xn divided by n. Okay, this is the arithmetic that you can find, you can find it here. Okay, and summation of fi means add all these frequencies that you will get the summation of fi. Okay, that we can denote summation of fi as a n over here. Okay, so this is the mean deviation for finding measure of a dispersion. Okay, this one is the mean deviation, guys. Okay, I hope you all have understood mean deviation. I took this lecture little lengthy, but just for your understanding I explained it little lengthy. Okay, I hope you all have understood measure of dispersion for mean deviation. Okay, so we have left here with the standard deviation. We go for the standard deviation in our next lecture. Okay, yes, just need to understand the formulas. I'm taking it for the formulas. At the end we go for some examples. Okay, I hope you all have understood my today's lecture, measure of dispersion for the mean deviation. In my next lecture I'm going to explain to you all for the standard deviation. So thank you everyone, thank you for my today's lecture.